Okay, so I got the green light from our organizer, which is Alma Mater Europaea University. Welcome to the 14th session, 14th edition of our yearly conference. It's about people 2026. This is our session on digital technologies and artificial intelligence in this year edition with many research papers from our students and from the colleagues, researchers in this topic. My name is Matej Mertik. I'm here the professor and coordinator of the programs of digital technologies. We have technologies on all 3 degrees, including the PhD program in applied artificial intelligence, which is unique in the region. That's why also we are having here many research papers and contributors from our colleague students that will present different aspects of AI today. We have today 2 sessions on the floor. So the first one will be bring together different contributions that demonstrate how AI is evolving across different domains. We will have foundation technologies to real-world applications in the second session, while addressing in both one important societal challenges and opportunities. And with the first cluster of our research papers that we will present today, we will begin with AI applications and AI applications and social implications. This is focused on the AI in areas as education, as sustainability, finance, and cybersecurity. We have 6 papers. I'm asking all of you presenters kindly respect 10 minutes of presentation here, and I will open the questions and answers sessions on the end of the first session. So welcome everybody again. I'm very looking forward to discuss with you, to listen all your contributions today, and we will start with our first presenter. I will ask to share the screen for him. So we are having Associate Professor Jorge Ferreira Franco from UNESP and ASMS to education by integrating pluricultural perspectives, arts, and Web3 technologies. So Professor Jorge Ferreira Franco, please, the floor is yours, the screen is yours. Please share the screen with us. Are you here? Welcome. Do we have Jorge Ferreira online? Can I check? Maybe if he's not here, we will go to the second presenter then, and then we will ask Jorge Ferreira to join us later if there is something with the connection, as he's coming from the Brazil. So I suggest we are continuing and we are presenting our second presenter, and this is Alexander Brotschneider. He's our student and Alma Mater Europaea. He co-authored the paper with Professor Matthias, comes from the Jorge Stefan Institute, and with Professor Matej Mertik from Alma Mater Europaea, and he will provide a comprehensive overview of very interesting topic, quantum machine learning and future perspectives toward quantum AI. So we will have some very nice and strong introduction to the AI technologies today, going to overview of the things on quantum AI. So Alexander Brotschneider, please welcome on the conference. The screen is yours, the floor is yours, and please, your 10 minutes is here. Thank you.
Thank you very much. First, I would like to check if you can hear me all and you can see my presentation.
Alexander, are you here? Can you hear us?
Yes. Yes. You can hear me?
Alexander?
You can hear me?
Yes,
Hello.
we can hear you. And we see your presentation, so you can start.
We are hearing
Okay.
you perfectly.
You can hear me, yes? Okay.
Yes.
Good afternoon, ladies and gentlemen. It's a pleasure to be here today and to present our research. I would like to sincerely thank Alma Mater Europaea University and my co-authors, Professor Dr. Matjaž Gams and Professor Dr. Matej Mertik, and all of you for your presence, time, and interest. Thank you very much, and let us begin. This opening slide frames the central claim of the work. Quantum machine learning is treated not only as a computational toolkit, but as the empirical base from which quantum artificial intelligence and later quantum generative AI may emerge. For the talk, I would open by positioning the presentation as a condensed conference version. So here we are, and 3 steps is the arc is 3 steps like QML, QAI, and QGI. Here, I would like to frame the problem. The research argues that the classical AI rooted in deterministic logic and classical statistics researches conceptual limits when it faces complex quantum information structures and emergent behavior. So quantum machine learning is introduced as a way to move from purely deterministic optimization toward probabilistic and interference-based learning. That is the launchpad for the rest of our presentation. This slide defines the analytical scope. The work does not propose a new quantum algorithm. Instead, it asks whether the literature already contains the conceptual ingredients for quantum intelligence, which methods dominate empirical validation, and how LLM integration may push the field toward quantum generative AI. I would emphasize that the broad search window starts in 2013, but included review sample effectively begins in 2017. Okay, this is the central conceptual model of the talk. QML is the empirical layer where algorithms and experimental validation live. QAI adds semantics, cognition, and the idea of intelligence as a coherence-preserving process. QGI extends further into generative systems, especially when quantum models are connected to language model architectures. I will explicitly state that this is a theoretical bridge, not an already verified architecture. This slide compresses the Prisma UR selection process. I will stress that the work is not based on isolated primary experiments, but on second-order synthesis. The logic is therefore about transparency and reproducibility, where records come from, why they were excluded, and how the final sample was quality checked. A useful detail for the audience is that older reviews were often rich conceptually, but weaker in systematic filtering. This is where I would reassure the audience that the corpus is broad enough to support synthesis. The included reviews are not clustered around a single algorithm family. Like I said, they cover fundamental quantum algorithms, hybrid architectures, application domains, theoretical models of quantum intelligence, and the recent linkage with LLMs and generative systems. That breadth is what makes the bridge from QML to QAI intellectually plausible rather than hand-wavy. The trend chart. My spoken emphasis here would be that the field does not simply accumulate more QML papers. Its conceptual center shifts. Like you see, the early years are mostly about whether quantum machine learning works at all. Later reviews ask broader questions about semantics, intelligence, autonomy, and generative behavior. That drift is exactly what motivates the QML to QAI bridge. This slide distills the algorithm families that recur across the review corpus. I would explain that the literature is not betting on one single bullet. Instead, it experiments with several families. You can see variational methods, quantum neural networks, kernel methods, and generative models. Across them, the same gremlins keep showing up: noise, bar amplitudes, benchmarking, weaknesses, and integration problems. That is the current reality check, and it matters. This is the punchiest result slide, and I will deliver it in 3 bits. First, the field is no longer purely theoretical. Second, hybrid systems are not a compromise to be ashamed of. They are the actual bridge. And third, the vocabulary of the field changes, and vocabulary is not trivial here. When researchers increasingly speak about meaning, agency, and intelligence, the paradigm itself is broadening. I will present this as a conceptual architecture, not an overclaimed engineering result. The idea is that QML provides, firstly, quantum representation and optimization dynamics. Secondly, an integration layer maps those outputs into semantic forms. And thirdly, an LLM layer acts as an interpretative and generative interface. So the research positions that combinations as the path towards QGAI. The key phrase to stress is conceptual feasibility and not current deployment. This slide keeps the presentation honest. The contribution is conceptual and synthetic. It organizes the field, proposes a bridge model, and offers a stronger interpretation of quantum intelligence. But the research also admits real constraints. First, there are not direct experiments in the study itself. Second, terminology remains messy, and some claims are still theoretical. So, for the future work, the agenda becomes clear: quantum agents, quantum semantics, and governance. I would close by simplifying the whole presentation into a 3-part message. QML provides the experimental base. QAI provides the interpretative framework, and QGAI names the generative horizon. The conclusion in this research is intentionally directional because it does not claim that quantum intelligence is solved. It claims that the path from quantum learning to quantum intelligence is becoming scientifically legible. In final, future AI may not simply be faster. It may be more context sensitive, more generative, and more deeply tied to the physics of information. Selected references, and thank you very much for your attention. I would again like to sincerely thank Alma Mater European University, my co-authors, Professor Dr. Matthias Gams and Professor Dr. Matej Mertik, and all of you to be here today. It has been a privilege to share these findings with you. As quantum and intelligent systems continue to evolve, the real question may no longer be whether machines can learn differently, but whether we are ready to understand the new epistemic horizons they may open. As we move forward, perhaps the key question is not only what quantum intelligence can compute, but also what new forms of knowledge it may enable us to imagine. Thank you very much.
Thank you very much to presenter Alexander Brodschneider. I would suggest that maybe the audience is writing down some questions for the end discussion. And now I will give the floor to our first presenter that I already announced. This is Professor Jorge Franco. I'm seeing him on the screen. Maybe we will have now the opportunity to see also his presentation. Please, Jorge Franco, welcome to the conference, and screen is yours to share your topic of AI and 3D technology.
Good morning.
Good morning.
Okay, you are listening to me well. Let me see if I can find here of the
There is a share button somewhere down, green one.
let's see. It's okay.
Okay.
Play. Is it sharing?
Yeah, I'm not seeing it yet, but it's in process. Yeah. All right. We are seeing your PowerPoint presentation. You can just move it to presentation mode and start your talk of education and web technologies, please.
Just a minute. I think now it's okay. Well, thank you for inviting me to be here with you. Good morning, everyone. And this work is based on my trajectory inside the K-12 school levels and beyond. I've been working at São Paulo Network Schools in the municipality. And
Sorry, just to interrupt you, we are not seeing all your screen. If you can do the presentation mode on a line that we are seeing your.
it's not appearing.
It is, but we are seeing only half of the slide because you have.
Half.
Yeah, better.
Okay?
Like that. Thank you. Yes, okay. Please
Okay.
continue. Yeah. Thank you.
Okay. It's okay. Then I'm participating in a group of students, like a researcher, collaborative researcher, and I worked in a primary school. Okay, and then I've been working in at K-12 school levels and also researching at Reich schools. The working itself is related to analyze the value of bringing of using pluricultural transdisciplinar intersection encompassing experimental learning, communication, and scientific knowledge, arts, and web-based technologies at K-12 education levels and beyond. I think this is important because it's not common inside the schools. We have access to technologies that are very advanced and used in the consumer, like video games, like research, something like that. And then using it inside schools can make us to grow up, think about better uses of these technologies, and how it can be crossed to and make it part of the curriculum itself, in terms of having principles of, an example, maths, arts, science, and how it is applied in the building of these technologies. Maybe it will help us in the future understand better the systems like artificial intelligence, like the Alexander was saying about quantum computing. So having principles of this inside schools can make the population more conscious what these technologies are and how to apply it in the future of their work or students' times. So we have done it by different approach using cultural approach in terms of an example. In Brazil, we have many artists, black artists that are not recognized. So by applying these technologies like Web 3D technologies based on 3D computer graphics programming, we can access this artist's artwork and then rereading them through computer graphics programming and bring it to inside to school, showing to the students the value of learning math concepts and technology concepts and mix it together. In this case, we use the artist was Rubem Valentim, one of his works. We make a rereading of that. One other example was this one is when we work a bit of with coordinates X, Y, and Z with children, and we explain them why they were learning it inside school and how it could be made, it could be applied through web-based technologies and programming and computer programming. So we learn a bit of English language, a bit of programming language, and also about cultural aspects of that are part of our world of arts. And sometimes we don't have access or don't have materials, physical materials for doing. So we could apply it with the students. Other example was this one, in which a student using this type of technologies build a environment based on Charles based on I forgot the name. Charles Chaplin, and so he used computer programming for developing a gallery and then researching and then use the algorithm, the small scale algorithms and mix them for doing this environment. And so working with texture, research, math, arts, and this is one of the possibilities that we have with this kind of technology for using with students. And here, let's go. We have one moment in the lab, computers lab when we were working with students from 8th grade. And together, boys and girls were learning a bit of computer graphics. In this work, I have the participation of the teacher that works inside this computer lab. So we did a very collaborative and participatory work with her and with the students. So this kind of work can bring about lifelong learning opportunities because we have students that lived this type of work with us and now are working as teachers using approach in the same kind of approach. Some of them did computer science, other journalism, but other civil engineering. And this is a transdisciplinary and participatory teaching learning way of developing scientific technical abilities. It can broadening women participation and also under socio-technical and socioeconomic disadvantaged individuals in the world of computing and the world of science and something like that. So can be important use Web3 technologies that are, a lot of them are free for educational use, and very accessible because they are part of the browsers, and so are in our laptops, in our smartphones and smart TVs and something like that. Thank you very much for your attention.
Thank you, Jorge. I will have short question on the end for you, considering your education and use of Web3 technologies. But as time is going, I would like to move to another presenter. And also for the audience, please have questions for Professor Jose on the end. Can you please?
Okay,
Yeah,
just a second.
So our next presenter is Attila Zoltan Girofi. I hope I pronounce it well. PhD candidate at the Faculty of Business and Economics, University of Pécs, who examines how AI-driven knowledge can support ethical and environmentally responsible behavior. So I'm warmly inviting him to share the screen with us. Thank you, Jorge, and welcome to the Attila Zoltan is with us. Can you hear us? Can you share the screen and your presentation? I will check if he's here.
I don't think Attila is with us right now.
Attila is not with us right now, so then I suppose we can go to the next one. If he's joining, we can integrate him later. So, and the next paper is also one of our PhD candidate at Alma Mater European University is Francis Noachvalo Gembe, who will present together with Professor Matthias Gams and Professor Maciej Wiglosz, present his work. The paper present bio-inspired hybrid AI model for cryptocurrency forecasting, and I'm welcoming Francis to the screen. Francis, screen is yours, and please, thank you.
Yeah, I think I'm loud and clear. Thank you very much, Professor Matej and Alma Mater, European University, and everyone who has attended this conference. The work I'm presenting today is about a bio-inspired spiking recurrent neural network with evolutionary optimization for non-stationary cryptocurrency forecasting. And I'm working with Professor Gams, Professor Wiglosz, and Professor Matic on this same project. Just a moment. Yes, the motivation behind this research is basically about cryptocurrency markets. And they exhibit volatility, extreme volatility, a lot of changes. And they have strong non-stationality and a lot of sudden regime shifts, whereby you can see Bitcoin chart today it's very low, tomorrow it's very high, and all that. These affect traditional models, which basically are well robust when it comes to linear relationships and stationary distributions. Nowadays, we have recent deep learning models like convolutional neural networks and normal recurrent neural networks, which still have several challenges, including overfitting, hyperparameter sensitivity, and instability under regime changes. So this is a gap existing in models used to predict what the price of Bitcoin or any other cryptocurrency will be tomorrow. Our goal is to develop a robust forecasting architecture that handles volatile financial time series forecastings. This is the goal of this research. And this research will investigate whether spiking neural dynamics can be embedded into recurrent neural networks to improve forecasting. And the main idea will be combining these three components. One, long short-term memory, temporal modeling, spiking neuron dynamics with the leak and integrate fire background, and also the Grey-Wolf optimization or evolutionary optimization for hyperparameter tuning. We will compare the results using the baseline, which is the Grey-Wolf optimization long short-term memory baseline model, with our proposed model, the Grey-Wolf optimization spiking long short-term memory model, to predict what the next day price will be. Basically, we download this data from Yahoo Finance from September 2024, 17th to June 2017 on 12th, and we did split the data into an 80 and 20 ration, whereby the training data set is taking the 80% ration, and the testing data set is taking the 20% ration, as you can see in the graph here. Our proposed architecture is simple. We do extract the data, do pre-processes in real time, window it up, and subject it to hyperparameter tuning using the Grey-Wolf optimization architecture for both the baseline and the proposed model. Our mechanism is to tune just two parameters, the learning rate and the weight decay. These are the parameters we're going to tune using the Grey-Wolf optimization architecture, whereby we have populations of wolves, the alpha, the beta, various populations of wolves, and these wolves do collaborate in their pack to either hunt, encircle, or attack a prey. And our play is to find the best suitable parameters that leads to high prediction results. Basically, this is the architecture. We have the models are standard, but we need to tune them well. We need to find the right parameters which leads to the highest predictions, and we want to find which of these two paradigms is the best according to our experiment. And we went on and did normal evaluations, and we also presented our results, as we're going to see. Basically, what is Grey-Wolf Optimizer? The Grey-Wolf Optimizer is a population-based optimization algorithm inspired by hunting behavior of wolves in the pack. And this involves searching for the best solution by simulating how wolves cooperate to locate and attack the prey in a way that it will involve consuming less energy. The need to find the next meal quickly, collaboratively, eat it, gain the energy to live another day to find another meal. If they chase the animal or the prey for so long and waste a lot of energy, they may fail to get that prey, and that may reduce their possibility of living another day. So to solve that problem, the wolves do divide themselves into teams, the strikers, the chasers, the finishers, and all that, with an objective of having the prey got. So here our objective is to find the best parameters that will help us have the best prediction results. And we have these populations, the alpha, which is the best solution, the beta, the second solution, the delta, and the omega. These are the remaining candidates in a population which we'll be following. And the alpha, beta will guide the search. And how does it work? We bring it out from evolutionary biology to now computer science. And we zero down to our two models, which are fine-tuned by these parameters, the learning rate and the weight decay. We first of all randomly initialize several wolves candidates with different parameters, randomly generate the parameters of the rate and worth, divide them into 5 packs or 5 categories, and then train the models, the two models, using both. We train the two models using both. We train the models using all the random generated initializations, and then try to see which sets of parameters lead to the highest results. And then we do rank the sets of parameters. With that, after 5 iterations, we're able to find the right parameters and grade them into the wolf packs. So this helps us automatically fine-tune the models instead of wasting a lot of time trying and erroring to find what works and what doesn't work. You could have the best model, you could have the best data sets, but you don't have the right configurations, and you don't have time to explore billions of configurations to find the best fit. With this kind of optimization algorithm, you delegate that to biology principles, and automatically the system finds the best parameters, which will give you the most optimal results to minimize the losses and maximize the gains. So I'm trying to get this. And these are some of the results we got when we compared our algorithms. We found out that in a nutshell, the growth of spiking long short-term memory has better performance results. Based on the root mean square error, where we look at the lower, the better, you can see we have lower root mean square error. The mean square error itself, the difference between the predicted and the actual results with the square root of the average, you can also see that it's also better or lower for the growth and throughout. So with this kind of research, we determine that the difference between the actual and the prediction is
Estamos a
When-
ciência, a Beira na festa tudo uma articulação redonda.
Soba me strani sobie.
Coisa boa.
Zaszło lahko.
when it comes to spiking long short-term memory growth optimizer algorithm, you have a higher chance of having a close or the actual prediction than when it comes to the baseline, which is long short-term spiking long short-term memory. As you can look at the predictions, we have the actual prices and the predicted prices. By delegating the activity of choosing the best parameters to the growth optimization algorithm or the spiking long short-term memory, you are most likely to have much more actual predicted results, though sometimes not very, very actual, but it's very, very close. And in financial market trading, this is what you need. You need to be able to find the best price. You need to be able to use the right model, which is most probably going to give you the most close price to tomorrow's price, so that you can make a profit. And the power comes from the ability to predict the future. And here we are predicting the future using nature. The way the animals utilize their energy in the parks to make a win, a catch, a kill, is the way we are doing it in machine learning, basically modeling spiking neural networks. When it comes to performance measures, you can see that in the long short-term spiking memory, the activity took very less time. This is the time complexity, meaning that you're saving energy resources and you're having the prediction faster. And this is good for high-frequency trading, where decisions are made in microseconds. The difference of 1 second can lead to a profit of $1 million or a loss of $1 trillion. And you need to know the following price, predict it fast, exploit it, determine whether something is going to fall before it falls, and you sell it, determine whether something is going to rise up, and you buy it, with an intention of making a profit or a difference from the buying and the selling price. And when you look at all the benchmarks, it is really perusable to use a spiking long short-term memory and optimize it with the Gray Wolf optimization algorithm to find the best prediction of the following day price. As I conclude, I say spiking recurrent dynamics improves forecasting accuracy, evolutionary hyperparameter tuning stabilizes the training, and the growth of spiking long short-term memory reduces prediction errors and runtime. The main contribution of this research is we really need to use these hybrid frameworks for its benefit, and we need to go bio-inspired to save the computational energy or resources and increase the time of the predictions. And we can say the concept of recurrent neural networks still works, but need to be used in the best way possible. And future work can be using this method on multi-asset validations, longer financial time series horizon, and also acquire neuromorphic computers to measure the real energies and try to publish the difference. As I conclude, I can say spiking recurrent architecture represent a promising direction for robust financial time series forecasting under non-stationary conditions. Thank you very much.
Thank you very much, Francis, for your nice presentation and sharing with us your insights of predicting trends with these different methods in AI, in neural networks. We could elaborate on it a little bit on the end. But we are continuing with our session, and I'm inviting to the floor our next presenter. Our next presenter is Giga Ivkovic, who is student at Alma Mater Europaea, and he will present work on AI methods for detecting unwanted SMS messages. He was working that with Associate Professor Andrei Drobovolts, also from Alma Mater Europaea. So Giga, welcome to the session, and please share your screen. Thank you.
Okay, hello. So I and Dr. Andrei Dobrovolts, we were working on a scientific paper with the title Use of Artificial Intelligence for Detecting Unwanted SMS Messages. It was an analysis of methods and experimental validation. So in this presentation, I will present my paper on the use of AI for detecting unwanted SMS messages. The work combines a literature-based comparison of methods with an experimental validation under standardized conditions. Spam SMS is an increasingly relevant problem for mobile users. It's not only annoying, but also associated with phishing, malware distribution, and financial fraud. At the same time, SMS messages are a difficult classification problem because they are short, often contain abbreviations, grammatical inconsistencies, and informal language. This makes them harder to handle than longer text forms, such as email. The goal of the research was to investigate and evaluate different artificial intelligence techniques for SMS spam detection and to identify the most suitable approach. The work first examines the literature and then validates selected methods experimentally on the same data set and under the same testing conditions. We framed the study around three main hypotheses. First, the AI methods can outperform simple rule-based approaches. The second was the performance depends strongly on the quality of the data set and the pre-processing strategy. And the third, of course, that deep learning models should achieve better results than traditional machine learning models. So in the literature review, we analyzed 28 studies and grouped the methods into traditional approaches and machine learning and deep learning approaches. The overall picture favors deep learning, which achieved the highest mean accuracy at 97%, while machine learning followed with 96%. And traditional approaches averaged at 92%. Deep learning also showed the lowest variability, while traditional methods show the highest variability. One of the main problems in this field is that published results are often not directly comparable. Different studies use different corpora, different pre-processing, different feature extraction, and different trained test setups. For this reason, the experimental part of this paper was designed as a standardized comparison using the same dataset and consistent testing conditions for all implemented methods. The empirical part used the UCI SMS spam collection dataset with a total of 5,538 messages in plain English. So the text data was pre-processed through cleaning, normalization, tokenization, and then represented either through vectorization for classical machine learning models or through embedding for deep learning models. This ensured that all models were evaluated on the same underlying corpus within a controlled setup. Based on the literature review, I implemented 3 machine learning models that was multi-nominal naive Bayes, support vector machines, and random forest, and 2 deep learning methods, convolutionary neural networks and bidirectional long short-term memory. To make the comparison objective, all experiments were conducted under identical conditions on the same data splits, and deep learning models were evaluated across repeated runs because of their stochastic nature. In the controlled experiment, NMB and SVM achieved the highest accuracy at 97%. SVM also achieved the highest F1 score. Random forest and CNN were slightly below them, while BiLSTM had the lowest F1 score among the tested models. So in this standardized setup, the machine learning models, especially NMB and SVM, performed the best overall. The comparison is not only above one summary metric. The error profiles differ across methods. Random forest behaves conservatively with very low false positive but higher false negatives, which means fewer false alarms but more missed spam messages. BiLSTM shows the highest false positives, which means more legitimate messages may be flagged incorrectly. So the best model depends partly on the operation trade-off we care about. In addition to classification quality, runtime is still very important. The machine learning models were considerably more efficient overall. MMB was by far the fastest, while BiLSTM required the most computational resources. This matters because a method that is only marginally competitive in accuracy, but much more expensive computationally, may be less suitable for in real world use. So the literature review suggests a general advantage for deep learning, especially in average accuracy and robustness. However, our experimental results showed that on short SMS texts and under standardized conditions, machine learning models such as NMB and SVM can perform as well or even better than the tested deep learning models, while being computationally cheaper. This means there is no universal best solution. The optimal methods depends on the dataset, the pre-processing strategies, and the practical deployment requirements. So the central conclusion of this paper is that classical machine learning remains a very strong and practical choice for SMS spam detection, even in a research environment, where deep learning often receives the most attention. Thank you.
Giga, thank you very much for your presentation, and very clear presentation, I must say. And with that, before we are having some questions from audience, and also I have some remarks here to open the discussion on the end. After all, there are some very interesting research presented here, and we could a little bit elaborate on in the end. We are having our last presenter for the first session, and this is Ana Rotownik-Omerzo. I hope she is with us, a PhD candidate at Alma Mater European University, together with Maja Rotownik, PhD candidate at Faculty of Electrical Engineering and Computer Science, University of Maribor. She will present a systematic review of cybersecurity awareness among older adults. So please, Ana, the screen is yours. We are seeing the screen. Thank you very much, and you can start it with your presentations. Thank you.
Thank you. Good afternoon. My name is Ana Rotonico Merzu, and I'm a PhD candidate in social gerontology at Alma Mater Europaea, and also an assistant at the Faculty of Arts, University of Maribor. And together with my co-author, Maja Rotonic, she is a PhD candidate in computer science at the University of Maribor. We conducted a systematic literature review titled Cybersecurity Awareness Among Older Adults. Our collaboration combines two different perspectives. From the social science perspective, we focused on the digital inclusion, aging, and social factors affecting cybersecurity awareness.
Well, from the technical perspective, we analyze cyber threats and protection practices. Digital technologies, nevertheless, bring many benefits for older adults, including easier access to services such as healthcare, banking, and public administration, as well as opportunities for social connection and lifelong learning. However, these digital environments create new cybersecurity risks. One of the most common is phishing, where attackers impersonate trusted organizations in order to obtain personal data. Such attacks often rely on social engineering techniques, which exploits users' trust or emotions. Research shows that despite technical protection, human factor remains the weakest link in the cybersecurity chain.
And from the perspective of social gerontology, the issue is particularly important because digital technologies increasingly shape every day in later adulthood, and understanding how older adults perceive and manage online risks is therefore essential for promoting digital inclusion and safe participation in digital society.
The purpose of this research was to synthesize empirical findings on cybersecurity awareness among older adults and identify key factors influencing their online safety. To achieve this, we conducted a systematic literature review following the PRISMA methodology. So we searched 3 databases, IEEE Explore, Web of Science, and Scopus, and the initial search resulted in 187 articles. After applying the inclusion and exclusion criteria, and after removing the duplicates and screening by titles, abstracts, and keywords, the final sample consisted of 14 studies included in the analysis. The results were then organized into 4 thematic categories, which structure the main part of our presentation. The first are the demographic and contextual factors influencing cybersecurity awareness. The second are the most common cyber attacks targeting older adults. The third were security practices used by older adults. And the last were the effective educational programs for improving cybersecurity awareness. My colleague will first present the topic from the perspective of social gerontology, while I would then continue with the technological perspective.
So the first category examines which factors influence cybersecurity awareness among older adults. One important finding of the literature review is that vulnerability cannot be explained by age only. So instead, cybersecurity awareness is shaped by a combination of different demographic and contextual factors. For example, studies show that educational level is positively associated with interest in learning about cybersecurity later in life. So older adults with higher level of education are more likely to seek information about online risks and protective practices. Another important factor is digital experience and digital literacy. Research showed that competence in using mobile devices and access to support networks significantly improves cybersecurity competence among older adults. Conversely, a lack of digital skills can increase fear of technology and reduce confidence in safe online behavior. The living environment can also play a role because older adults living in non-urban areas may have less access to support, training opportunities, or reliable information, which can make recognizing scams more difficult. And finally, several studies highlight the importance of life transitions, especially the transition to retirement, because retirement may reduce access to informal technical support from colleagues or structured learning environments, which can increase exposure to online risks. So overall, these findings suggest that cybersecurity awareness among older adults is shaped less by age itself and more by a combination of resources, digital skills, and social support.
So the second category focuses on the most common types of cyber attacks targeting older adults. The literature shows that the most attacks on older adults rely on social engineering techniques, which manipulate psychological factors such as trust, fear, curiosity, or urgency. Among the most common threats targeting older adults are phishing attacks, identity theft, online fraud, and romance scams. Romance scams are particularly concerning because attackers establish an emotional connection with victims through social networks or other online platforms in order to gain financial benefits. These attacks are effective because they rely on psychological manipulation and not purely the technical vulnerabilities. In addition, emerging technologies such as deepfake scams are creating new challenges for recognizing fraudulent content and online deception. The third category examines the security practices used by older adults to protect themselves online. The literature shows that many older users adopt basic protective behaviors such as avoiding suspicious emails, verifying the credibility of information sources, and avoiding public Wi-Fi networks. Among digitally more literate adults, practices such as using 2 or more factor authentication and paying special attention using online banking are also relatively common. This suggests that many older users are aware of potential risks and try to behave responsibly in online environments. However, more technically demanding practices such as regular software updates or advanced security settings are less frequently used. Another important finding is that many older adults rely on family members or other informal support networks when dealing with digital security issues. This highlights the importance of intergenerational cooperation in maintaining cybersecurity.
So the last group of our articles is that educational programs, because training and awareness program are widely recognized as one of the most important interventions for improving cybersecurity awareness among older adults. And our literature review identified 2 main educational approaches. The first approach includes digital supported learning models and technological platforms designed to raise cybersecurity awareness. And the second approach consists in in-person educational workshops where older adults learn through direct interaction with trainers and peers. The analyzed studies show that particularly oriented and socially supported learning environments are the most effective for older adults, And the training should focus on technologies that participants already use, such as smartphones or online banking. And these explanations during the training should be based on a simple analogies and real-life examples, which help participants better understand abstract cybersecurity concept. So learning is also more effective when it takes place in small groups where participants can ask questions and receive individual support. So, in addition, effective programs include regular practice of security behaviors, such as recognizing phishing messages or creating strong passwords. So, digitally supported approaches also show strong potential because they allow scalable and accessible training. But, however, the literature review reveals an important research gap because most studies describe prototype learning models that have not been yet systematically tested in real world settings. But in addition, direct comparison between online and in-person training programs remain rare.
So, to conclude, cybersecurity awareness among older adults is influenced by a complex interaction of social, technological, and educational factors. Older adults are not necessarily the most common or the most frequent victims of cybercrime, but they can be particularly vulnerable once targeted. So, our findings highlight the importance of tailored educational programs, accessible digital environments, and strong social support networks. So, bridging the gap between technological development and safe digital participation of older adults therefore requires an interdisciplinary collaboration between social sciences on one side and computer science. Only in this way, we will create a safe digital environment for so-called silver surfers. So that's all, and thank you for your attention.
Yeah, thank you very much. This was also very nice presentations from the aspect of social gerontology and education, as we saw with our first presenter, who has presented the experience of web technologies and education. So I'm opening the floor here for audience for some questions for the articles that have been presented. We have saw the educational approaches, and this is where the last article was presenting how to use AI and what are the trends and experiences in educating older people. On the other hand, we have saw in the article of Jorge Franco also the experience of educating the younger people there, and I have some questions here also for this both educational aspect of the session, let's say. So for Jorge Franco, if he can elaborate a little bit on how he's using AI with these 3D web technologies and raising awareness of that. And maybe also the same aspect for the last presenter from Maya and Anna. When you have done this research, how you see that AI tools are enabling that, or what are your exploration in this sense also when you were preparing the research? Maybe Maya,
Hello.
you are on. Hello.
Okay, when we talk about the use of AI for cybersecurity and aspect of older adults, we need to think about the level of digital literacy. So the first thing we need to make sure is that older adults are know how to use AI models and how to use them safely. So the first thing we need to make sure is that they are aware of what AI models can do and how they can use them for their own benefit. I think AI can be a powerful tool for raising awareness and learning about maybe what is safe and what's not. So instead of going to family members for questions, they can use chatbots for this purpose.
Okay, thank you. And Jorge Franco, maybe from your perspective, And
If you
yeah,
speak, please. In
yeah,
my
maybe,
perspective, inside schools, we could use, for example, the algorithms of computer graphics. They are about 10, 20 lines. So we can read with children, talk about how the system as a whole use that lines and how artificial intelligence can be implemented. In terms of, I did a small scale experiment with them, and then an example, write algorithm for doing a sphere. Then how to animate that one? Then you go to the artificial intelligence prompt, ask it for the language, in this case, X3DOM, X3D, and they brought a small scale algorithm saying how to make the animation, and then reading that one, we can speak to children. Why it's important to know what is in the background of artificial intelligence, and why it's important to know technical skills, because we can have more power for doing our experiments and understand the things as a whole. So we can learn to know what's behind the prompt technology.
okay. Thank you very much. And also, others, I'm encouraging you to ask these aspects because of course, the education is changing fastly with all these large language models. And I know that Jorge Franco was already presenting to our conference his approaches in Brazil of using web and semantic technologies on that. But maybe just I'll explore a little bit the second topic that was presented on this session. And this was some nice articles of using machine learning and AI in different domains. One we had heard from the Francis Noah. He was presenting the two types of neural networks comparison of doing some predictions of cryptocurrency, Bitcoin. And we saw also same kind of research presenting different machine learnings and neural networks models when doing the classification of SMS messages. So from this aspect, maybe there are some questions or my comments, and maybe for the Francis first. Francis, how long this research has been implemented? Maybe from the timeline part of you, if you can elaborate a little bit on that, also our students can get a feeling. And what kind of the computational power behind did you use to do this, let's say, research and very nice results as you present with the computational and timeline dimensions?
All right. Thank you, Professor. We've just finished this research, and we've just submitted the paper on for reviews, the results and everything today. So this is a new research, and we used a simulator for neural networks called SNTorch, which runs on GPUs and CPUs. For this particular project, I used the CPU version, and I did not measure the computational power. I concentrated on the reverse, which is time, to substitute how much does the model consume against the other. So I used what we call time complexity, not basically if energy consumption, but if something runs very fast, that means it uses less, which is the implied meaning at the moment, because we don't have a real neuromorphic processor right now to benchmark this, to have actual measures of spikes consumption, energy consumptions. We had to change the metrics to time complexity. If it's very fast, it means it consumes less. And I believe if this is tested on a real neuromorphic computer, a brain-inspired computer, which is a computing paradigm similar to how your brain works. That means the Grey-Wolf architecture really means a lot, and it saves you from, maybe let me give an elaboration. Why this method? I've been doing machine learning for the last 6 years. You could have the right data, the right model, but you may spend 6 years, I'm telling you the fact, 6 years, trying to find the right tunings to give you the best. You may always believe that your model is wrong, but usually sometimes the problem is the tuning. Make sure that the model fits the data to give the right prediction. And most machine learning projects fail on that. With this intervention, we are automating the process. We are giving it to nature. We want things to fine-tune themselves, find the best solution. That's what we are delivering.
Talking about both great strategies, right?
Yes, so we have two strategies, give them the same tool, and one strategy excelled in producing the best results automatically.
And
That's
maybe,
it.
Francis, just for our students that are not so familiar maybe with the AI field at the moment, but you mentioned also neuromorphic architecture behind. If you can just elaborate a little bit on that, what is this from in very simple phrases that people can grab the main idea.
Okay, now we have AI, and this AI has generations. We have what you call first generation, where you have a normal perceptron, a mathematical equation representing a neural network running on a CPU or a GPU. Then we have second generation, where we have now multiple deep neural networks, like we have neurons, but these neurons have layers. So within the middle, you could have thousands of layers and parameters. That's what ChatGPT uses, the transformer models and everything. That's deep neural networks. And now we have the third generation, whereby we are not only relying on mathematical models to represent the neurons, but we are relying on biophysical principles or biophysics principles, the normal principles governing how your brain works, using the voltages, the amplitudes, how the spikes receive the signals and send them to, are excited and accumulate the excitement and then send it to another neurons through another spiking. We have the post and the pre-spiking neural networks operating together. And you need now another form of computing, the computing which will process these spikes or these voltages just the way how the brain will. And this kind of computing is what we call neuromorphic computing, because neuromorphic computing doesn't have a centralized memory system. It has a distributed memory system. We don't have movement of data from the processor to the memory in batches. Data is processed where it is residing, just like in your brain. The neurons do the processing and they pass back their feedback until you have the decision or the understanding. In this kind of computing, since there's no movement of data, we avoid a common computer science problem called the Von Neumann bottleneck. The Von Neumann bottleneck, whereby you have a limitation on how much data moves from the processor to the CPU. Okay.
Okay.
Now there's no movement of data, therefore things are processed where they are. So we have faster computations. That's what neuromorphic computing is about. It's a paradigm of computing which consumes less energy, less time, and better results. And is the best solution for third generation AI. Thank you.
And have different also hardware architecture behind, as Francis mentioned. Francis, thank you very much. Maybe just a short elaboration on Giga work. Giga, how long your work take place also from the aspects you have presented to us, different methods for classifications, and it was quite also very nice and very carefully done experiment in machine learning and AI. So maybe just short from your side.
So my work was quite shorter. Actually, it took around 9 months because my work wasn't so deep. You see, the first part of my work was only reading papers and gathering results from others. So that part didn't take very long. The other part where I validated tried to validate the findings from the research. That took a little bit longer, but still, my paper didn't go so deep in how every model works by itself. It was basically a meta-analysis with validation. But still, it was quite interesting because I couldn't actually validate what I found in the theory. Of course, I know I had quite limited resources while training and testing, and also my data set was quite limited. I chose the data set because most of the other studies used the data set, but this data set is still only 5,000 messages, and it is kind of perfect data set in only in English and with just here and there a couple of aberrations. It is not quite a real world data set like we would find here locally. For example, in Slovenia, we have if we would do that here, we would have a mixture of at least 5 different languages mixed together with I don't know how many combined words of this. So it is hard to tell what would the findings be if we would test this here. Well, but still, what I could found was that when we put all the methods that were described in different articles together and tested them on the same data set, the picture wasn't quite so clear as in the other papers, because the other papers all told basically that deep learning is almost every time better, but it kind of isn't. We still found that machine learning is, of course, it's computationally very much better. It requires far fewer resources, but the actual accuracy is on par with deep learning. Of course, it is hard to tell if it would be the same in different data sets or from different countries. But in this plain English data set, machine learning and deep learning are both quite equal, and most important, both are actually really, really good at classification of spam SMS.
And thank you, Giga, for mentioning that, because also our students and colleagues are well aware of this. So there are many dimensions when we are doing data process and we are trying to do the systems for prediction. And one of the dimensions is also the computational accuracy, the time for that, everything around that. So thank you for that. And the last presenter that was in this session is something, another field, which is called quantum computing. It was Alexander Brodschneider who presented the literature review, and I'm sure that he has most complex terminology on that. And maybe the same questions for him. So Alexander, if you can elaborate a little bit, that others will have a feeling how long this research is taking place, how many time you have invested to do this meta analysis of the articles on that, and please also elaborate a little bit on, because this is completely kind of very different field as neuromorphing is, the quantum field, and it requires quite a lot of time also that you are, let's say, getting a little bit familiar with this another kind of computation, let's say, like that.
Yes, thank you very much for listening and the opportunity to be here. Yes, I was, I'm doing this research from nearly about maybe a year and a half now, because it was also for me a lot of new things inside, and I didn't understand a lot of new things but in the meantime, I started to recognize some pointers, and yes, this is like how to make the final goal is how to make our computers more faster and cheaper energy, less consuming. So this is an answer with quantum AI. Like hybrid mode is most relevant today, and also in the market, there are so many stocks are raising about quantum computers and all this stuff and projects. So this is a very interesting field, like it was years before with AI. Now there are all signals that there's this like a next trend to where it's good to be in, no? And I'm very enthusiastic about this. And I hope that this my presentation was our presentation. Sorry, is we are three co-authors here. Give some design to you, some futuristic, inspire your futuristic mode of thinking and researching. So yes, I hope I will do this in again. I mean, to prosper here, and I will let you know about new findings next year.
If I might comment just on that, it's very interesting because this is a completely new area. I mean, the quantum computing is not something that is from yesterday, but with all the development of the technologies now, this has more and more focused, and there is more and more improvements on that. And of course, quantum physics is something that we are quantum computers all with universe included, I would say. And it's again the complete different architecture as von Neumann is or neuromorphing. So there are some different flavors of what computation today is. And I'm very happy that we can have the opportunities also to hear from our colleagues and students to explore these areas, because it's something that is worth exploring. And it's something that is going on in the field of computer science. So classical computer science, neuromorphing, and quantum computing, these are now two new domains within the classical computer science that are having much more gravity. And with that, I'm also opening the floor. If somebody else have some question, not only me, I was just trying to summarize the session and to summarize the research presented. Now I'm giving the floor to you, to students and to colleagues here, if there are some questions we could elaborate on.
Can I ask a question?
Of course, please.
Anna, please. You told about security related to aging. In the case of in the country I live, we have problems with literacy. So, do you have any suggestion for dealing with security with old people that don't have literacy skills? I know it's hard, but
the most effective are these intergenerational context between like these so-called silver surfers. So they're these older who are like from the baby boomer generation on the one side, and intergenerational context with the digital natives, so young people. These programs and these trainings are the most effective because the older ones have more, they trust younger people more than, for example, the adult ones. So these different intergenerational programs, for example, in nursing homes or maybe at home, they are the most effective. While some trainings online or, for example, some propaganda are not working so well as this contact for them.
All right, and also a kind remark here, please exchange your emails. Yeah, you can elaborate further on. There are some interesting connections that might happen now during all these different research being presented on this session. And if there is some other question, I'm still giving the floor. If there is no other questions, then I would suggest that we are having the coffee time, and we are again recuperating. Now it's in only 4 minutes. But yeah, please.
I would just like to ask about a neuromorphic thing that you research for Gamba and yours. I'm very enthusiastic about this because also about transferring memory from human to machine. So there is a problem with this chemical issue. The voltage is okay, but is there some keys that is in neuromorphic also is possible maybe, or we are nearer to decode these chemical connections and interference maybe?
Yes. Right now we have already new materials printed using nanotechnology, where they do print neurons or extract neurons or neural networks from living human beings, and then they program them. And then they can use those as the materials for the Neuralink technologies to control things like prosthetics. You have an interface of a machine which is for your hand, but the way it connects to your body and neuron, it uses a biologically printed material, the connection. And also this can be used to transfer even memory or expand and all that. You can read about Neuralink technologies where we have numeric brain-computer interfaces inspired by neuromorphic computing, whereby the machines connected to the people or to the living organs have the same processing principles as the living organisms themselves. That is the brain-computer interface. Yeah, thank you.
This is great. Thank you. This is the next thing, to transfer human memory to machine and maybe be a robot and learn forever. Live forever.
For instance, two people were connected to discussing a dream using these brain-computer interfaces. Two people had shared a dream orchestrated by the electrons on a computer. I'll share with you the experiment, and you see how people dreamt using this kind of technology. You dreaming with your wife in another country over the internet, and the dream is connected to these neuromorphic computing principles.
That's nice. That's the next. Thank you very much.
All right. Yeah. Thank you.
Okay, so we are approaching to the second session. I would suggest that maybe we would make a 5 minutes of the pause. So we are gathering here 16:35 in good 5 minutes, just for you to have a short walk. And then we are continuing with the next session, which will be AI, more technical oriented. We saw in this first one the application, and looking forward to see you all with next 6 presenters. So for the moment, 5 minutes of thank you very much.
Thank you very much.
Okay, so welcome back to the second session of Web and Information Technologies and AI. As I mentioned already before, we are continuing with our session 2, and this session is it's more oriented to advanced IT technologies and intelligent systems, when we will explore some cutting-edge methods and architectures again across multiple domains. And we will start with presentation of Henok Teklu, who is a PhD candidate at Alma Mater European University, together with Professor Maciej Wiglarz and lecturer Mustafa Saki for AGH University of Krakow. He will present a study on event-driven pedestrian crossing detections using spiking neural networks, which is also the research which is connected with our research project at university, digital twin project. So Henok, please, the screen is yours, and welcome to the session and to the conference. It's all about people. Thank you.
Hello, everyone. My name is Henok Teklu. I'm currently a PhD candidate in applied artificial intelligence here at Alma Mater Europea. This is work done by including me and Professor Masaj, and Mustafa, Dr. Mustafa. The whole topic of this work, which is an ongoing project about how we can use spike neural network for pedestrian crossing detections. So to just give you some kind of outlines about the introduction, about the problem statement, why pedestrian crossing detection matters, why we use event-based instead of just frame-based like cameras instead, what is like our proposed spike neural network architecture, what is the maths behind this architecture, our experimental results that we already have, and we do some kind of comparisons, and we'll show you what's the conclusion in the future works. So what is the current challenge that we are facing? The main problem is like the intent inference. Predicting pedestrian behavior from incomplete signals. This is very challenging. So a pedestrian might like in the way of crossing, but it is very hard just to understand about their intent. The other thing is like the problem that we are facing now. Most of these pedestrian detections or any detections are using a frame-based camera, which sometimes will fail due to like this rapid movement because the frame is like 30 frame per it is like based on frame. So whenever there is like a high movement, those like frames might not catch or just have an understanding about that leads to blurring. The frames are very much fixed. So we are just consuming a lot of power because this is a very fixed frame based. When it comes to some adverse conditions like rain, fog, and low light, we have a very challenges when it comes to using frame-based algorithms. So our approach is instead of just using a camera, we use dynamic vision sensors, which leads to a microsecond resolution, which is very different compared to frames. We have used, since we have like these event-driven sensors, we try to use a biologically inspired temporal dynamics, which is spiking neural network architecture. On top of that, we also have used this transformer approach, which is adaptive. And this is parameter free, so it will just accelerate. So the main target is how we can predict in real time. So we train the algorithm. Can we predict in real time? Well, just the pedestrian are crossing. So this is our approach for this work. This is the difference between both like the frame-based camera that we usually use or the current technology on the cars that they prefer to use. It is fixed, fixed capture. It doesn't like change, or it doesn't like, it is always on this kind of frames. For each time step, we need to have like these full frames, which leads to a high computational power. It is susceptible for motion blur whenever there is like some kind of fast movement. We have a very redundant static data. So when we capture images within very small seconds, all we get is like a very redundant and also static data. Static data, that's something that we will be struggle with. So this will lead to high bandwidth consumption. So our approach is to use a synchronous event output. The output is in millisecond temporal resolution. It just captures only the brightest change instead of just getting all the static information. The data set that we get from this device file is more brightest change. A sparse efficient representation. It just uses a high dynamic range capabilities. So there have been previous works. Some they have used the DVS approach with different problems for edge detection, corner detection, time surface representations. Most of these pedestrian detection that are now currently available, they prefer to use an approach with frame-based like cameras, and the algorithms, because it is like camera or images, they heavily use convolutional neural network for this kind of algorithms. But our approach, which is different, we use like spike neural network. At the same time, we use a different data set for DVS data sets that we get from a Carla, which is a simulation. So the whole architecture is as follows. We need to first do some kind of temporal aggregations. This will just give us some broader picture about the whole image that we have from the DVS. Once we have this temporal windowing with aggregated values, we convert them into spike form, because spike neural network we need to have like these spike values or spike formats. So we need to change this the original data set into spike threshold spike forms. So the spike is based on threshold encoder. So it just converts the value from 0 to 1 based on the threshold that we set for this temporal windowing. The second step is, once we have like these spikings, we don't just convert them into informations. We need to have this accumulator where we accumulate spike informations before just giving to output. This makes the whole approach to be more based on accumulation of, like, let's say, voltage. Instead of just using a single voltage, we need to accumulate informations to make sure it is spiking again. After we do this kind of we do adaptive modulation. The adaptive modulation helps us to select and to enhance some of the spike informations instead of just using as they are, because this will just make this assume it is as transformer. It helps us select the most important spike informations. Finally, we just pass it through our binary decision output, which is crossing and non-crossings. So this is a mathematical representation of the whole algorithm. Spiking are based on a certain type of threshold. We say for the algorithm, whenever it is above a certain threshold that we want, which is a dynamic value, just do spike. But if the whole accumulation, like voltage accumulation, is lower below this threshold, just leave it as a zero value, which doesn't have more information. So the whole things will be aggregated into 0 and 1. So 1 will have some kind of information. The zeros have it could be like a background, a noise, which we don't need. That makes the spike neural network algorithms to be more fast, because those unnecessary information, like a background, something that they don't have, like a change in brightness, would be excluded. So we can make the whole inference to be more fast. Yeah, the algorithm that we use for spike neural network is Leaky integrated fire, which is based on change in the voltage change based on derivative of a certain time. So it just accumulates information from previous data, and for some of them it needs to be leaked because some of the information are not necessary. Strong information will be kept and will be added with current information that we have. With this way, we create or accumulate.
Okay. But if you can conclude because of the time limit, thank you.
All right. So because of this, we do some kind of approaches. we need to do a reset. This is a typical like spike neural network algorithm, how the spike neural network algorithms. So the other, we add some parameter-free adaptive modulation, which helps us to select the most important or clip onto very specific information that makes the whole algorithm to be noise-free. This is auto-adaptive information. The parameters are auto parameters. So we did training based on cross entropy loss function with unique or just different class weightings. So going back to our experimental results, we have found that all the approach that we did with a single image, with some kind of using 9 frame and 30 frame and doing a repetitive work, we have seen that all of them have a good accuracy above 89. So we feel like if we use like a spike neural network for this kind of problems, not only just the accuracy is higher, but also the inference time is lower. So this helps us to make sure that the pedestrian crossing would be more accurate. So this is the total performance things. We have also just checked on like adverse weathers, like whenever there is like some kind of bad weathering, we have seen that it is consistently outperforms and becomes a good when it comes to accuracy as well, both for normal condition as well as for adverse weathers. Let me just pass this one. So the whole point is we can use spike neural network, which can help us to make sure that the pedestrian crossing detection is more good and perfect if we use this DVS dataset, which we have like simulated based on a CARLA dataset. This is an ongoing project, so we are also looking how we can use a normal images or normal camera images. We convert them into as a DVS form. So we are looking how it can perform well, not only on the CARLA dataset, which is a simulated dataset, but on real environments, which we also are looking at. We're also like experimenting a good result. So this is the whole algorithm. The spike neural network is not only good for the performance and the inferences, but it also is neuromorphic efficient. That makes the whole process to be less energy consuming process. And thank you very much.
Thank you, Henok. Thank you for sharing with us your research work on, again, Francis was before explaining SNN, and Henok is also using this kind of technology for concrete applications, as you saw. But as we are again on the end, we will open a little bit the questions and answers. So I'm warm welcoming here our next presenter, who is assistant professor Tal Pavel. Is also working at our alma mater, European University, and he will have an interesting talk offering now the comparative analysis of cybersecurity education programs in the Western Balkans. So not connected so much with AI at the moment, but a very interesting thing, because as we know, the cybersecurity is even more important today as AI in some fields because of the situations as we have, and we all want to have safe web. And Professor Tal Pavel, welcome here, and I'm giving you the floor.
Thank you very much, Professor. Am I audible? Yes. Okay. Thank you. So once again, thank you very much, Professor, for the invitation and the honor and opportunity to be part of this most interesting, professional, and important conference and panels. As said, my presentation, now you can see it, I think so. My presentation is, let's say, perhaps on the edge between technology and some less not totally oriented topics, technology oriented. I mean, as mentioned, my topic is cybersecurity education in the Western Balkans, and my aim was to explore the diversity of dedicated cyber education program in public Western Balkans academic institutions. Okay, now let's see. What we'll cover, it will be short. Literature review, the methodology of the paper, research question finding, and of course the conclusions. Let's start with the literature review. Well, as can seen, there are not much of academic research that delve into this topic of dedicated cyber programs in higher academic institutions in the Western Balkans. So there are some cybersecurity education in Kosovo, cyber risk management in the Western Balkan higher educational institution, but it's the cyber risk management. It's not the education by itself. Comprehensive cybersecurity strategy in the Western Balkans, digital skills for the Western Balkans, and of course, cybersecurity evolution in Albania after the massive cyber attacks that they experienced. So regarding the methodology of my paper, my research, first of all, what is the Western Balkan? So the definition of the European Cluster Collaboration Platform, it defined Western Balkan as a group of countries that are targeted by the European Union enlargement policy. This group is originally constituted by Albania, Croatia, North Macedonia, Montenegro, Bosnia and Herzegovina, Serbia and Kosovo, but Croatia joined the European Union in 2013 and hence is no longer targeted by the Western Balkans EU policy. So I focus on Albania, Albania, North Macedonia, Montenegro, Bosnia and Herzegovina, Serbia and Kosovo. Now, what is my methodology, what I did? Well, first of all, search for the different academic programs in each higher academic institution. I mean, to find first the public academic institutions, and I focus myself only in this search, in this research only on public academic institutions to find those public academic institutions in each and every country. Then the different programs in each of those universities and higher academic institutions, and then to try to find the word cyber, either in English or in the local language. And of course, to find to what its attribute, whether it's a news or to a dedicated summit program. The research questions were as follows. The main research question was how are, first of all, a dedicated cybersecurity program. I mean, I didn't look for a course here, a course there, but a dedicated cyber program distributed across public universities. I mean, as said, I looked for such dedicated cybersecurity programs in especially public universities, and not private one, sorry, and in the Western Balkans. The sub research question from the main one cover the regional patterns. I mean, what are the regional patterns to try to compare such dedicated cyber programs between countries, different countries in the Western Balkans. The second one was related to the local patterns. I mean, in specific country in the Western Balkans, whether we can find patterns in, for example, we can find such academic dedicated cyber programs only in universities that are located in the capital or in the big one. That's regarding the local patterns. The third one was the type of the public university. I mean, it may relate to technology-oriented or something that relates to security services or security or defense, to the defense apparatus. And the fourth one was the academic level. I mean, first, the second, the third, bachelor, master, PhD, what are the academic level of those dedicated cyber programs? And the fifth and last one was the faculties and departments. I mean, in which department? What is the orientation of such programs? And of course, it's cyber, but under which department and faculty? The findings. Well, I found that, as you can see in here, when we examine those 6 Western Balkan countries, those are the numbers of public higher academic institutions. As you can see, in Albania, we have 14, North Macedonia, 7, Montenegro, 2, Bosnia and Herzegovina, 10, Serbia and Kosovo, 8 in each of them, and totally 49 public higher academic institutions in those 6 Western Balkan countries. And when it's come to the findings, that is interesting. I think so. And here you can see the number of higher academic institutions, I mean, as saw in the previous slide, but the number of programs, the number of dedicated cyber programs. And you can see that one here in Albania, one in North Macedonia, one in Serbia, in one academic institution, that A, and B, provide only one program. At the end of the day, we can see that only 3 academic institutions, public one, provide 3 dedicated cyber programs. And you can see the name of the institution, the name of the program, and the unit, I mean the department or the faculty. These are the findings. What are the meanings, the conclusions? Well, interestingly, as mentioned, only 3 out of 49 public higher academic institutions in the Western Balkans offer a dedicated cyber program. Public higher academic institutions in Montenegro, Bosnia and Herzegovina, and Kosovo do not offer such program at all, as so. Each of those institutions provide only one dedicated program. 2 of the programs are national defense and security. And I think that's very interesting. That's very interesting. We speak of cyber, and at the beginning of almost each course of mine, I ask the student, what is cyber for you? And in most of the cases, the answer are technological oriented terms. And here, 2 of the 3 academic institutions that provide dedicated cyber programs are those that relates to defense, national defense and security. Only the last one, only one is information technology related department. And we can see it here, okay? In Albania, it's the Academy of Armed Forces, and the program is Professional Master Cybersecurity in the Field of Defense. And in Serbia, as well as the University of Defense, and the program is Military Electronic Engineering and Defense in Cyberspace. Only here in North Macedonia, we can find Master of Science in Internet Technology and Cybersecurity. Once again, it's important to mention that I didn't look for a course here, a course there, but a dedicated cyber program, which is called Cyber Program. So those are the conclusions. Future research may cover several other aspects or enlarge the picture to have perhaps a broader one. Dedicated cyber program in private higher academic institution in Western Balkans, because my research focus on the public higher academic institutions. So a future research might may expand it to include also private one. Another research may analyze the synergy of such programs. I mean, not only 0 or 1, whether such a dedicated program exists and offered by such a program or such institutions, but what is the content? What is the syllabus? Sub-education program by the local Ministry of Education. I mean, what are the instructions, regulations? What are the local Ministry of Education's initiatives when it's come to sub-dedicated programs, sub-dedicated education programs? To try to compare those findings with other states in the Balkans and now European countries at large. And in addition, to try to do the same thing regarding AI program, AI dedicated programs in the Balkans, in other countries. So those are my conclusions and domains that I thought that may be interesting for such a future research. Thank you for listening. This was my presentation on cybersecurity and higher education, public institutions in the Western Balkans. Thank you very much.
Professor Pavel, thank you very much for your presentation. I will make a short exception here and will just ask you one question because I think it's quite interesting from my aspect.
Yes,
if you can comment, why you choose only public institutions? Just curiosity.
Thank you for this important question. Several reasons. First of all, I wanted to focus on what is the, I will not say the official, but since public one, contrary to the private, reflecting, let's say, the governmental perception, the Ministry of Education. So it was as a first step to try to understand how the state regard dedicated cyber programs. Of course, later on, as mentioned, it may be another one that will focus on private one. That's the first reason. The second one is definitely there are much more private academic institutions than public. We saw 49 in those 6 countries. I assume that there are dozens, if not more than that. So to start with this niche, I try to focus and to a bit minimize myself into this one, and then perhaps I can do a zoom out to a much larger population of to include private institutions as well.
Okay, thank you very much for this clarification, and thank you very much for your presentation. Now we will move to the next presentation, which will go to the healthcare applications with our PhD student from the AI program, and this will be the presentation by Kennedy Ado, PhD candidate at Alma Mater European University, together with Professor Uroš Marušić, Professor Matej Merting, and Professor Maciej Wigloš, presenting research on Alzheimer's disease classification using AAG data. So, dear Kennedy, thank you. Floor is yours. Screen is yours. Be with us and share your. Can you do the presentation?
Hello. Thank you very much for the audience, and thank you for the opportunity. Before I go ahead to do the presentation, I would like to use this opportunity to acknowledge Professor Uroš and then Professor Miladinovich for their role in this presentation. I'm Kennedy Ado, Alma Mater University. I'm presenting on electroencephalography-based Alzheimer's disease detection using resting state, EEG, and then random forest classification. You know, Alzheimer's is a very important condition that if attention is not paid to, it becomes something like a condition with a disability. So it is very important we see how best we can manage those people with neurodegenerative conditions. So Alzheimer's is a neurodegenerative condition that affect human cognition or that also lead to memory loss and incapacitation. So it is very important we devise strategies or advanced forms of machine learning to see how best we can help such people with, those neurodegenerative conditions. The focus will be automated detection of Alzheimer's using electroencephalography signals. No data set is obtained from OpenNeuro resting state EEG dataset, which is publicly available dataset for managing people with Alzheimer's conditions or any other neurodegenerative conditions. Now, in terms of methodological approach, the study will focus on feature extraction of EEG signals, relying on random forest classification. The goal is to identify reliable EEG biomarkers for early Alzheimer's diseases or detection. So the biomarkers, we are looking at people with biological processes, whether it is of protein origin, whether it is of hormone. It is very important we see how we can use these reliable EEG biomarkers to diagnose them. Now, in terms of the introduction, like I have already emphasized, Alzheimer's affects cognitive decline and also lead to memory loss, which may lead the patient or the client to some kind of disability. Now, early detection is meant to improve management. We have used or utilized some conventional or traditional methods that has to do with magnetic resonance imaging, positron emission tomography, cognitive tests, but they are very expensive and it also presents some kind of complexity. So on the basis of this, we seek to introduce EEG, which is meant for providing non-invasive. When I talk about non-invasive, what I mean is that it doesn't subject the human being to any surgical intervention or it doesn't introduce any instrument. It is also predicted to be high cost effective. And they also have high temporal resolution. So the focus is going to be eyes closed EEG that is focused on stable baseline activity. Now the problem statement, just as to reconfirm the introduction, it is time consuming, costly, EEG is complex and noisy. So we need to devise a strategy whereby we can have an algorithm that is capable of doing away with the complexity and also minimizing noise. So limited features reduce accuracy. Once you don't have it tuned to large data set of information, it is bound to lead to a lot of inaccuracies. Therefore, we need robust machine learning methods for high dimensional EEG. The goal is to detect neural patterns where we can lead to prediction of accurate predictions of people with such conditions. Then, in terms of study objectives, the study seeks to explore EEG-based Alzheimer's detection using machine learning algorithms. The specific ones are to analyze resting state EEG signals, and then we see how best we can also extract meaningful features that is being of temporal or spectral. And then we also look at how we can rely on random forest algorithms to do the classification for better prediction of diagnostic accuracies. Like I've already made it very clear that we resort to using publicly available data set owned by OpenNeuro, and the focus is just about resting state eye close. And then we are going to rely on multi-channel brain, imaging data structures. That is just meant to support reproducible or replicative neuroscience research. Now, in terms of the methodological approach, these are going to be the flow chart or the flow diagram for the analysis of ECG signals. The first of all will be EEG data that will be trained on large pool of data sets in terms of the processing. Then in terms of extraction, you will see how best we can extract meaningful large data sort of information relying on random forest to support people with such conditions. So the pre-processing phase will also seek to filter and then remove any artifact that is sought to cause any disturbances or noise while remaining at a state of rest. Feature extraction will also look at spectral features. That also ensures how best we can get frequency bands that can lead to predictive, accurate results. Now, in terms of feature extraction, if you look at the diagram here, you will see that we have temporal features. The temporal features sought to analyze mean, variance, build complexity. Then the spectral features will also look at frequency bands. That has to do with delta, theta, alpha, and then beta, width. And then again, we see the patterns. If you look at the feature importance, random forest has the capability of doing effective classification among people who are classified as healthy and those people with unhealthy situations. So you see entropy through to the theta. So the bars here are indicative of the EEG signals having the ability to extract features of importance or significance. Now, in terms of classification, random forest is an ensemble decision tree that combines multiple array of trees to lead to predictive, accurate results in terms of exposing those with Alzheimer and those without Alzheimer. Other forms of approaches have been tried and tested, but it is believed that random forests stand a chance of making right predictions, especially targeting those with Alzheimer conditions, because it handles high dimensional data, and then it is also very important for controlling or minimizing noise, and then again overfitting, which is a major feature in other forms of algorithms. So the goal is to do comparative analysis between those people who have Alzheimer and those without Alzheimer. Now, these are preliminary observations, even though they are not validated, but we are just of the view that because it is still work in progress. So these are benchmark to do proper validation when we get available data set from OpenNeuro. Then in terms of the preliminary finding, just as I said, we will see how best we can increase delta or theta, while we also want to reduce alpha. And all these are very important when you look at the frequency bands, especially in looking at how best we can look at spectral, detection of those people with such conditions. So machine learning detects EEG biomarkers with the support of EEG that is considered as more non-invasive detection tool. Now, these are the results. The results is indicative of the fact that the algorithms random forest is able to classify those people who are considered with Alzheimer and those with healthy state. But if you look at the confusion matrix here, it is indicative of the fact that the matrix shows some individuals with healthy state and others who were also misclassified. This is indicative of effectiveness of EEG-based detection. Then performance of evaluation metrics of the EEG-based Alzheimer classification model. So these are the performance of the model, how the model performed. So if you look at the bar chart here, in terms of accuracy, the random forest has the tendency to make predictions up to 91%, and then in terms of precision rate, it is guaranteed of about 89%. Then in terms of sensitivity, it has up to the tune of 92%, and then specificity up to 90%. And it also has high F-score of about 90%. This is suggestive or indicative of the fact that the model is very strong for predicting people with such conditions. This is further confirmatory study in terms of application of AUC, that is just symbolic of how robust random forest algorithm is in terms of predicting people with such conditions. So if you look at the chart here, AUC is map up to 0.94, which is suggestive of what? Model performance or robustness. The study significance. The study is meant to promote AI-assisted neurological diagnosis. This is also meant to validate EEG as a biomarker, encourage the use of what? Open neuroscience data set. And this one has the tendency to also assist clinicians, especially as patients with such condition present their cases very early. Conclusion: EEG plus random forest present a promising, tool for detecting those with what? Abnormalities in terms of Alzheimer's disease. And then again, resting state EEG also is scalable. This one is just how innovation could spread, and it is more replicative. So future studies should, governance for large data set of information, also rely on deep learning or multimodal integration, which is very important for retooling in terms of assisting those people with such conditions. These are the available or the supported references that guides the presentation. Thank you for giving me audience.
Thank you, Kennedy, very much. As I said, on the end, we will have short questions, answers, if there will be a time. But now we are moving forward to our next presenter. Again, the PhD candidate from Alma Mater European University, Ilona Erika Negro. She will present us exploring the human-centric dimensions of labor in AI-driven economy. Ilona, welcome to the stage. Welcome to the conference. Hopefully you are here and you will be able to share screen with us in a few seconds.
Thank you very much, Professor. And I'm very honored to be able to present my research here. Thank you very much for the opportunity. Let me share my screen. 1 second. Okay. Share. Okay. Can you see my screen now?
Thank you. Thank you. Can do the presentation mode.
Okay. Yeah, sorry, one back. Yeah, so I would like to present to you my research on the slow food of labor, the human-centered niche in an AI-driven economy. Well, prevailing narrative in recent years has been that the higher educated we are, the better the chances that we avoid automation, our jobs avoid automation. Well, recent research has shown that the picture is much more complex than that, and there are highly educated jobs with tasks that are easily automatable, and there are medium-level jobs with human capabilities that remain difficult to replicate technologically. And this is very well explained by the task-based theory of technological change, mainly by David Autor and colleagues, that whose central insight is that automation substitutes tasks, not entire occupations. And if we take this as granted, and that certain tasks are easily automatable, then it raises the question, what are the human capabilities that are more difficult to codify and scale? And my research is based on this theory and takes it one step further. Through the human-centric resilience framework, it looks at human capabilities embedded in tasks that are difficult to automate. And for that, it looks at a very specific target group in the leisure care and personal service economy. We are talking about hairdressers, plumbers, massage therapists, childminders, child workers, pet groomers, pet trainers, landscape gardeners, so on and so forth. So you may ask, okay, what is common in all these professions? But first of all, they are accessible, widely accessible professions. They do not require tertiary education for entry. They provide person person, people-to-people services, physical body in physical setting, unstructured environment like new homes, new animals, new people, new bodies. They involve physical proximity, so they cannot be performed via Zoom, and they don't have a prescripted way to perform. Each and every situation is very different. And I'm showing you where I took my data from. So this is the human-centered resilience model. Sorry, I minimize this. That stands on 3 distinct pillars of capability clusters. And all data is taken from O-Net, which is the official labor market database of the United States government. And beyond job descriptions, it includes very granular capability variables. I've taken these from those ability skills, work styles, and work context. And in certain cases, most especially in the 3rd pillar, I had to use some structural boxes for underlying capabilities. So I mapped these capabilities on the 3 pillars of embedded dexterity and skilled movement in unstructured spaces, agency and adaptability, and emotional labor. And then I calculated the composite index, which is a weighted index in line with the theoretical literature on the challenges of automation. The 1st pillar was weighted 40%, and the other 2 pillars received or were weighted 30%. I calculated and compared the scores for the target and control group, and I'm going to show you the results. But before that, I just want to do a quick retour to the title, The Slow Food of Labor, to explain the philosophy behind this research. Well, when fast food appeared, it provided scalable, fast, and standardized alternative. A burger was a burger. And what we can see is AI operates currently on the same premise. It provides scalable, fast, standardized services widely available. And what happened with the fast food is it did not replace slow food. On the contrary, it gave rise to a slow food movement, which then valued authenticity, deep customization, and the human attention that prepared it, and commanded a premium price for such a service. And in an AI-driven economy, when such cognitive services are becoming widely available, scaled up, and cheaper, and human interaction is automated, what remains scarce is the human factor itself. And what is scarce? Scarcity drives value. According to the theories of Pierre Bourdieu, authenticity and scarcity alone is able to increase the economic value. So based on this assumption, there could be some work that would retain or gain economic worth, not in spite of being performed by humans, but because they are performed by humans. And so this would be the slow food of labor. And now let's see if and to what extent the results underpin this assumption. On 2 of the 3 pillars, the first, embodied dexterity and skilled movement and emotional labor, the target group scored significantly higher on the first pillar with a very large effect size. To put this into perspective, compare a robot on the assembly line assembling a car, or in an Amazon warehouse in a standardized alley, arranging boxes, compared to a plumber who is trying to navigate through a uniquely shaped dimly lit basement to reach and repair a rusty pipe. So it is, of course, highly possible that with the fast development of automation, such dexterity and fine granular dexterity will be possible. But the caveat is that we are looking at realistic deployment conditions, and deployment conditions in a warehouse or in a lab setting are very different from the real life, where there are constraints of, first of all, human safety, security, liability, user trust and so on, and institutional constraints. And actually that provides sort of a safety network or safety layers for this pillar, or for tasks or work in this pillar. And if you don't mind, we take the third pillar as the next one, which is emotional labor. And some of you may immediately ask, okay, why emotional labor? Generative AI is perfectly able now to detect affective cues and react with the appropriate answer, as we have seen in all the headlines, how people trust their digital chatbot friends. Yet in such type of context where people often feel vulnerable, think about a home care aide bathing an elderly patient, elderly lady, or just think about your beloved pet that you take to the vet, or you take to the hair groomer or the dog groomer. This gives a sense of a vulnerability, asymmetric relationship where people need trust, they need to feel trust, they need to feel safe, and they need to feel empathy. And well, empathy requires what we call reciprocal social participation. And AI cannot be reciprocal because AI is not embodied, it doesn't have a body, doesn't feel pain, and is not mortal, it's immortal, and has all the time of the world. So it has no stake in the game. And interestingly, sociological theories underpin that humans attribute different value to emotionally supportive responses, depending on whether they perceive that it comes from a machine, or they perceive that it comes from humans. And besides, if we think about the increasing free machine interactions and the authenticity, the scarcity of authentic human presence, time, and attention, this distinction between slow food or slow work again emerges, suggesting that perhaps that could be a second protective layer of such work. And now let's take the second pillar, which is agency and adaptability, which was a surprise pillar, because given that all these jobs operate in highly idiosyncratic environments, every situation is new, every dog is different, every hair is different, every person is different, every house is different than the garden. So these people have to adjust on the fly, real time. I expected that their adaptability and agency score will be skyrocketing. And what happened is that the control group scored slightly higher. So I was wondering what the reason for that could be. And in fact, this will be a subject of another study. But the assumption is that taxonomies such as ONET are more focused on capabilities that can be formalized, and they reflect that descriptors reflect adaptability more in terms of planning, evaluation, rather than real-time situational adaptability. And this tacit experience-based knowledge that lives in the hand of a dog groomer when a dog's body begins to tense up and knows how to react, this is very difficult to formalize. It's not written anywhere in the paper. Actually, it exposes a big challenge of machine learning, because machine learning relies on data, and you cannot really automate what you cannot articulate. So this is difficult to observe, difficult to put on paper, difficult to record in photographs. This is something that is called tacit knowledge. And interestingly, if you approach it from this perspective, actually this inverse result may suggest the third protective layer around such work, because it is just simply difficult to grasp and describe, and therefore difficult to automate. Now, a few words, and before I go to the implications, I would like to just mention one interesting finding. ONET has a classification of bright outlook. It provides some professions with an outlook, with a bright outlook, which means that there is market demand, growing market demand for such jobs, high number of vacancies, and the growth is projected. And 69% of the occupations in the target group were classified as bright outlook, as opposed to 33% in the control group, and the control group was all the other occupations. So what does it imply? I think one of the most important implications is that we have to approach automation a bit differently. As the task-based theory of automation implies, automation is not happening at the level of education, it is happening at the level of tasks. And therefore, education alone does not mean a safeguard against automation, and this is confirmed by the data and also by independent labor market validation, if you will, because of these bright outlook classifications that actually apply twice as much to the target group as to all other occupations. And there appears to be a structural differentiation in the labor market, because as digital and scalable services expand, the demand may rise for something that is getting scarce, that is human attention, authentic human attention, and human presence, and situated expertise. And this is also captured by the bright outlook. Now, regarding education, does it mean that we don't need any more education because this is no protection against automation? Actually, this is quite the contrary. Lifelong learning should receive a new understanding. It's not periodic upskilling from time to time any longer. We are talking about constant capability development, including the integration of the latest technology that allows the augmentation of work. And workers that will be able to combine the human capabilities, their specifically human capabilities, with the augmentation provided by the latest technology will be very well positioned in the future labor market. And that leaves us with the last question, which would not be what jobs will be automated, but rather how should we design technologies that augment human capacities in the labor market. Okay, so, and thank you very much.
Yes, thank you very much, Ilona, for this nice presentation. I think that there will be some comments, questions on the end of the session. And I would like now to thank you and then move to further presenter, which is, just a second, I have here the list. So the next one is Senzi Mokofeng, again, the candidate from the University of South Africa, PhD candidate. She is studying applied artificial intelligence. It's from the same program as we have heard the presentation at the moment. And she will present a convolutional neural networks approach to pneumonia detection in X-ray images. So Senzi, welcome with us. If you are here, please share the screen and we are listening to you.
Okay, I hope I'm audible and visible.
You're visible. Please do the presentation mode and you're free to go, please. Thank you.
Thank you so much. I'm a student at Alma Mater, and this paper has been with the assistance of my professors who are on the call, and Prof. Oros. So my study is, I'd also like to just correct that I'm a candidate of Alma Mater Europea, and I work for the University of South Africa. I will be looking at pneumonia detection using convolutional neural networks. My presentation is structured as follows. I'll start with the introduction, literature review, methodology, results, discussion of results, and conclusion. With the introduction, about 1.2 million pediatric episodes occur globally with regards to pneumonia. And in 2016, 880,000 kids were lost because of pneumonia. And the recent results show a slight decrease in that number of 725,000 kids who have, or children that have died of pneumonia. However, pneumonia is curable only if it's detected at an earlier stage, and the tools, the diagnostic tools to detect pneumonia are easily available in terms of X-rays that are lower costs compared to CT scans. The global challenge, though, is that it is the leading mortality key or disease, to put it lightly, especially for children under the age of 5. The issue as well with detecting pneumonia is that there's variability and subjectivity with the experts that detect pneumonia, with a 60 to 80% variability. So one radiologist would say that there is an indication of pneumonia, and another would say there isn't. So there is some subjectivity in looking at the X-rays and detecting pneumonia. The other challenge is that there is a shortage of radiologists around the world, and the solution is artificial intelligence, in that we can use convolutional neural networks to detect pneumonia. It is efficient, it can be accessible in remote areas, and the results are compatible to experts. In summary, just an overview of the challenges. There's variability in expect results of pneumonia detection. There are resource constraints, and there's a problem that in younger kids it is difficult to detect pneumonia. In terms of the literature review, I extracted a couple of papers that are important, that have used convolutional neural networks to detect pneumonia, and the measure for those have mostly been accuracy, precision, or the area underneath the curve. And in those, you can clearly see that there is a high number of accuracy across the papers. I'd also like to highlight that there are other architectures in terms of pneumonia detection that are housed within convolutional neural networks, and those are listed: Dense Network, ResNet, MobileNet, VGG, and Convolutional Next. The architecture that seems to be the most accurate, or the best in the market currently, is VGG16 and VGG19, with an accuracy of 99.5%. In terms of the methodology, I accessed CADL, and I found X-rays for children, and the usability of that data set was at 7.25, and I had accessed that data set from a publicly available network, which is Kaggle, and 50% of the data was used for training, 30% was used for validation, and 20% was used for testing. In terms of the architecture for convolutional neural networks that I had used, the inputs were pictures chest x-rays for kids, and I had refined them to 64 pixels, 64 by 64 pixels, using red, green, and a blue color scaling, so that the model can read them and extract the features accordingly. I used 2 layers of convolutional networks, and this is the layer where the learning occurs, where there's data extractions, and the background from the pictures is sort of blurred out, and the lungs are shown. So the model uses feature extraction to see where there might be differences in the pictures. In terms of max pooling is it's that level that improves the dimension. So there was a reduction in the number of pixels from 64 pixels to 32, and then it moved on to the next convolutional layer, and in that layer it could read 18,000 patterns. Moved to the next max pooling session, and it further reduced the pixels of the picture from 32 to 16, and then in the flattened layer it changes it changes the picture form from pixels into numbers, and then in the final, that is the fully connected layer, where now the learning and the features have happened. There were 131,000 connections or features that the model could learn from, and then the output level was binary, whether the child had pneumonia or not. So these were my results. They did not look that great in terms of accuracy, and in terms of accuracy, it's 72%, which is far less than what my literature review has indicated. But later I will show you why the model is still significant because of its recall score. So in the training, it trained the model, it came up with 72% accuracy. In the validation, it improved slightly at 73%, and the number of iterations that the model could learn. So epochs means the number of iterations that the model goes through, a complete iteration to learn using the data, and it went through that process 29 times. Now, my results that I found impressive in this test was that the model could accurately pick up all the pictures or the x-rays that had pneumonia. So I had 100% recall score on this run, and in the test data set, the 20% data set, there were 10 pneumonia pictures or x-rays, and the model accurately picked that up. However, there are limitations, and future studies that we could look at. Firstly, the data split into 50, 30, 20 could be improved. The accuracy score of 72 to 73 is way low, below the standard, based on previous literature that has been done. And the test size, the fact that there were only 10 pneumonia x-rays is insufficient statistically, and I would have to increase the data set. The fact that I only used one data set, I need to include or incorporate other data sets, and there is a limitation in that if I had to use primary data, then there would be ethical and regulatory requirements. So I think I will stick to secondary data even when looking at the final paper. In conclusion, what is required for future studies is that We need to look at the explainability and what features the model used. We need to look at multi-site clinical validation studies, because this one only focused on children, and the source of the data was from one particular clinic. We would have to extend the data sets by incorporating other data sources from multiple ages, and multiple ethnicities. And also looking at the architectures that I can use even further within the umbrella of convolutional neural networks. I can look at VGG16, ResNet 50, or DenseNet, as literature had indicated that VGG19 and 16 provided the highest accuracy scores. These are the references that I have gone, the literature that I've gone through, and I would appreciate feedback. I hope I am on time.
Thank you, Senzi. Yeah. Thank you very much. We are having a little delay, but I think that they are very nice presentations, so I didn't interrupt it. We are continuing now with the next our presenter, and the next presenter is Tony Lenko. So I will give Tony you the screen to share with us your work. And welcome, of course, to the session of AI and digital technologies at Alma Mater Europaea. It's About People conference.
Thank you. Thank you, Matej. You can see me, right? You can see slides?
Yes, perfectly. Everything is perfect. Thank you. So please.
That's great. Beautiful. Yeah, thanks for having me here. So my name is Tony Lenko, and today I want to talk a bit different, something about fundamental. So not just about artificial intelligence, but about trust in artificial intelligence. So because without trust, AI cannot scale responsibly in society. And fundamentally, this is not a technology problem, it's a human problem. So the core question I was asking, and probably many people asking, is can society trust AI? AI is already entering all the critical areas everywhere we work. We can see how many presentations we have now also at the conference. So many things change here. And at the same time, many times we're asking, we don't know exactly where the data is coming from. And I believe we heard this today. Many times we can't explain decisions coming from AI systems. And all this creates a growing gap between AI capabilities and human trust. So this is not just theoretical, of course. We can see what's happening in the world where I live. We can see AI now in daily use in so many fields. And if AI gets it wrong, it's not just a system failure. It's actually we have a human consequences in this space. So the systems are incredibly powerful. We can see capabilities growing on a weekly basis, but often very difficult to understand, difficult to verify, or essentially difficult to trust. So we face 4 key issues the way I see this. We see a big issue of unknown data origins. We see a ongoing discussion about black box decision making. We see bias and fairness risks, and we see lack of accountability. This is something that probably will repeat many times today. So AI gives us the answer, but often we cannot answer a simple question. The question, why did it actually make this decision? And that brings us to an interesting thought or question again. What if we enable AI to actually have a memory and accountability built inside? And this is where we start talking about AI provenance. That means we exploring the space where we could track the data where the data comes from, potentially record all the decisions, and also verify all the outputs. So instead of guessing, we can prove what actually happened. And how would that work? So in this space, we can see what's really shifting in this space from something we can't really truly see what happened to something accountable. And on a very high level, the flowchart I'm presenting here is showing the difference, not just in the flow, but also what sits behind each step. So every stage becomes, in the provenance, it becomes based on verified data. We can produce locked decisions, and also this all leading to auditable outcomes. And most importantly, human is not removed from this process. The human becomes the central point. So instead of asking, can we trust this AI system or this pipeline, we move to a much stronger position, and we can ask, can we actually inspect how the certain decision was actually reached? This is the fundamental shift where AI becomes traceable, bounded, and defensible, not something of completely different concept. Let me present. This is something I was working on a project with Queensland Museum. So I'm presenting from Australia, and the last project that actually just completed 2-3 weeks ago with Queensland Museum was pretty much a huge learning for me and our team in this space. So we applied this approach in a project here with the museum in Brisbane, in Australia, and it was a highly complex problem. So it was problem of cultural provenance. And this is not just about data, it's about history, it's about identity, it's about ownership. The challenge was quite significant because we stepped in with very fragmented and incomplete data records. We didn't have clear ownership of artifacts, and also lots of information was spread across documents, research documents, and also oral knowledge. So knowledge that elderly they carry within them. And also, on the other hand, also the goal of this project was not really just technical, but it was actually help to identify artifacts' origin, and at the same time also support the return to the right communities. So we speak about here, the focus here was in Aboriginal artifacts, Australian Aboriginal artifacts. What we built was not just certain AI model, but we actually built a governed reasoning pipeline. So the system that would actually work through multiple reasoning passes, the system that would combine data, historical context, and expert input. We did assessing the evidence uncertainty, and at the same time, we also had input from the elderly, from the people that actually live in a community. And the most critical, the most important thing what was in this process is that every single step through this AI pipeline was traceable, was logged, and was at the end also reviewable by humans. So instead of asking curators at the end to trust AI, we gave them ability to actually understand how decisions are made. They could challenge certain decision, and of course also at the end, curators also able to communicate with the certain community and explain them why they actually placed certain artifacts in their own community. This leads us, of course, the thought process and everything what we learn is giving us idea that we actually want to reach this level of trust. If we want to reach this level of trust at scales, we have to enable institutions and systems certain level of formal governance layer around AI. What we learned, the impact, and just to recap what actually we have at the end of this project is on the practical level, we enable automated previously manual workflows. We introduced structured provenance tracking for artifacts. We improved consistency and accuracy of assessments. And very important, actually also bring the trust and empowerment to communities with repatriation with these artifacts. So these are operational gains and operational results, but actually the real impact In this case, with Queensland Museum, was actually even much deeper because we moved from the process that was uncertain and fragmented. We moved it to a traceable process aligned with the governance that museum was actually dictating. And that changes how decisions are made. So curators are no longer relying on disconnected information, but they're working with a system where reasoning is visible and outcomes can be explained and justified. So most importantly, actually, especially in a conference like this, we translate this. This was enormous value that was leading to better outcomes for indigenous people. And because of this context, we are not just processing artifacts, we're supporting cultural recognition, ownership, and return back to communities. All this brings us actually to the next step, where we understand now that AI doesn't just need to be powerful. We can't just speak about capabilities, but we're stepping into the space where we'll have to speak about how AI systems are governed. Traditional, if I give from this diagram, you can understand, and we spoke about these traditional systems. They give us one answer. In most cases, we can't really understand the output, or especially not reasoning behind that. While now in the future of governed AI system will have a multi-step reasoning, will have a traceable steps through the system, and decisions will be able to audit and review. And that's actually something that I continue, and my team, we continue to work on this with museum. Plus, we're actually stepping now in a health space to work on this. Very interestingly, actually, and very happy to mention this is so something very important actually happened just last week. I'm not sure if everyone knows about that, but European Union actually endorsed the world's first international treaty in AI governance, and it actually happened exactly, I think, 9 or 10 days ago. And that will change a lot for the future. So that means for the first time, we actually speak with organizations, will speak about need to prove how decisions are actually made, how systems are constrained, and also we speak about accountability. So we're moving from the question for organization, do you have AI policies? We come to the space where we actually speak about show me the proof, or actually we can speak about AI must be auditable in this case, and accountability comes on a completely different level. So this is kind of wrap up to, and actually a perfect match for us, that what we learned from museum. So we explored from this research, the pilot from Queensland Museum, and as I said, we continue work on this. The final message, final learning from my side is, I believe that AI must remain human-centered. It's not about models and algorithms, but it's about decisions that affect people. And for that, the trust becomes foundation, which means transparency is required, accountability is non-negotiable, and governance is becoming mandatory. So the future of AI is not just about intelligence and capabilities, but it's about making systems more trustworthy. Because at the end, AI must remain about people. Thank you.
Tony, thank you very much. And with that, we are coming almost to the end of our session. And I know it is very, we are 10 minutes in delay, but and it is very not convenient for our last presenter, who is our PhD student, Nina. So dear Nina, apologize for a little bit delay in the schedule, but we are giving you 10 minutes now to present your work, which is also very interesting in AI and technology. Nina is also the PhD candidate student from our program in AI. So Nina, please, if you are with us, share the screen. Welcome to our session and hear your research work. Thank you.
Okay.
Thank you for having me. I'm very honored. So I try to be effective, quick, and having that in mind. So I'll just start with the explanation. Explainable AI is very interesting. So it continues with this my session, what I wanted to say to you. So I'm working in a telecom sector, so that therefore I'm working also with issues like spectrum management. So I'm very much interested in AI-driven spectrum management and AI-driven network slicing in 6G networks. So I move on just to see. So the challenge is we are moving towards 6G networks. So it's expected to be after the year 2030 in practice. So we are facing the 5G maturity, but connectivity service that will be in the future will need extra ultra low latency and massive data rates and biggest intelligence. That's why this is the challenge. And for if you didn't know, spectrum is a limited natural source. That's what is so. It is also very much regulated, and so it is dedicated by the regulatory bodies, so that therefore it is so important that we face also the regulatory policy with that. So the solutions that is proposed now with the new regulation is going from traditional static spectrum allocation to dynamic AI-driven management that faces real time. So that means that when you need a spectrum, you're going to get it, so that your service on wireless networks is functioning like it should, wherever and whatever you need. So why network slicing? Well, network slicing is a technology well known in software application that enables the creation of virtual isolated networks on shared physical infrastructure to deliver dedicated services and for supporting diverse users. And now that we are facing the AI challenge or data challenge, I would say, it also challenges in resource orchestration, spectrum efficiency, and real-time adaptation amid fluctuating demands and interference. So goal is to facilitate dynamic allocation, to facilitate predictive analytics, and to face adaptive policies, topology optimization and orchestration, enhancing efficiency, and supporting autonomous decisions. So my hypothesis was that we need to distinguish different AI algorithms for network slicing, because they need different explanations to address equity and governance issues. So I used quantitative perspective analysis of related standards of ETSI and better regulation standards. So my research question was how various AI techniques align with the regulatory approach, including the proposed Digital Networks Act, which is still under construction and still upon debate, to define the obligatory spectrum sharing, which means intra and inter-service frequency sharing, and to face those challenges with the priority rules, coexistence rules, interference protection, and defining geolocation databases. So I found out that in radio frequency, there are all of the AI techniques are used for different tasks. So machine learning is used for classification, prediction, and clustering, and for slicing recognition, but it lacks of common labeling standard and to ensure the high quality standards. And it's only used for network as a service. So therefore it gets some attention, but it still lacks some technological maturity. Deep learning is very common used in digital twins for predicting network congestions and proactively prelocating the bandwidth and computing power. As machine learning, it depends on huge data labeling, and it acquires some shared understanding among the users of that data. So we have to know where the data comes from, like previous speaker told us. So reinforcement learning is the next one. That enables policies to change dynamically in resource managing and for network conditions, such as adaptive routing and scaling of network slices. But this technique is also limited because it doesn't go beyond the scaling of the network slices, and therefore it's not matured enough. So, sorry. So, okay, so deep reinforcement learning is there are agents that really do contribute to the policies for slice admission and scaling and termination based on SLAs parameters like latency and reliability, but they are relying on a dynamic database, but at this moment it is not attainable yet. Federated learning is very much commonly used for classification of devices from local equipment, but it is lacking the explainability when it performs the statistics to the main agent. Graph neural networks is the next one, and it's very much used in core networks for processing graph structured data, but it doesn't go beyond that. It's perfect for topology, but it's not useful for other applications. The next one and the last one is very much used, and it's getting more attention. It is large language models, which are emerging in so-called intent-based networks. That means that you use your natural language to specify what you want, and giving you the goal, not how the process, how you want to achieve some issues. So it is go beyond the performing auto scaling, but it's very relying on collected statistics and historical data. Therefore, it is very using LLMs in radio frequency assignment is very limited. And for the questions, why don't you use it in dynamic spectrum sharing? It's because it's in this kind of the time, critical decision making is essential. Therefore, the delays can occur when it comes to decision. So that timely guaranteed decisions are not guaranteed. So each of these techniques has some benefits and some limitations. So my finding was that many of AI methods meet the core of the new DNA regulation and ETSI zero touch management requirements for service, but they are still not mature enough to guarantee the explainability, real-time data quality, which is essential for making good decisions. My proposal is to build an objective regulatory framework and guidelines to guarantee the equitable spectrum access for non-discriminatory prioritization and platform that could use the efficiently real-time data, and of course for bridging that technical and regulatory bridge. So I hope to develop my research in the future basing on dynamic spectrum and to face on really intent-based dynamic spectrum management. Thank you all, and thank you for your attention.
Thank you, Nina. Thank you also for your understanding, as we are having been a little bit in delay with time. But regarding that, on the end, as we are already after the schedule, maybe I can open 5 minutes discussion for anyone who has some questions. You saw some very interesting presentations in these sessions. I'm just underlining some varieties of that. Very nice work done by Professor Tal. We saw the situation in Balkan states about the education in cybersecurity, which is a very important field. Then we saw a lot of articles from our PhD students, including last Nina, which they're using AI, different methods for applications on the different fields. So very, very nice work also, including the Henok and Nina and others. And if there are any general questions, I forgot to mention Ilona, which is doing also fantastic research in his area of robotics and interfaces with how the work will change and how everything will change, and is changing. Basically, you are all noticing that by your everyday work already. So I'm opening the floor for 5 minutes, not more, because the time is appreciated and we use it basically. But still, I think it's all what people, it's conference for us, also for the students, short discussions, if anybody have some particular questions. So please.
I have a question for you all, because we need to face from different industries the benchmark for currency.
Yes,
Madam.
yeah,
and fast flow is in fact
Sasho,
can you help us? Thank you. So Nina, please, if you can say again.
Yeah, we faced the benchmark for currency, so because we have systems that are really impacting our lives, in health, in education, in job market, in spectrum sharing. So we need a benchmark for all of that. What I'm interested in is your opinion about that. How is it 92 in a currency? Is it good enough or not? So, because they are really high risk systems therefore that is my question. But what's your opinion about that?
Okay, so will somebody take the comments to Nina about benchmarking? Because I think the benchmarking generally is very different in the field. Sometimes same, but very dependable from the topic that you are doing, but still much more clear than, for example, Kennedy, can you mute your phone, please? I cannot do it for you. Thank you. So much more clear than in I don't know, in social sciences, for example, right? So we are much more clear, but still not so clear. Has anybody have some comments on that?
Yes.
Yeah,
Nina?
please go
Hi,
ahead.
Nina. Hello, this is Francis. My first professional work was to work as a software engineer in a telecom company, that is French Telecom, Orange. And I have an idea on what you're talking about. And I also worked for the government of Rwanda on band rationalization and the spectrum distribution. What is lacking is what you've pointed out. And I believe there are initiatives that can be taken. For example, Telecom Slovenia, where you work, can offer to provide data, and that data can be publicly available for students at alma mater, and we can kind of like create a laboratory and then do research using that data and publish. That will result to creation of internationally recognized benchmark that will help Telecom Slovenia and the entire telecom fraternity at large, and that will also help alma mater students have real-life projects that can actually fund their scholarships. With that, I believe it can be established. Thank you. So
Thank
we
you,
need
Fran.
yeah, and we can, I think, secure funding for that.
Thank you, Francis. Anybody else?
Can I have a quick question to Tony?
Yes, please.
Tony, what are the challenges in this governance? What about decision heuristics? What about biased training data, or maybe the reliability of evaluation or hallucination? How can you filter these in for a reliable audit?
Yeah. So actually, this is overall, this is something I've been on this task on the task of bringing trust to all the systems actually for a very long time now, for 5-6 years. And with AI, what we're actually doing, and I was just presenting on a Queensland Museum case, is basically what we enable is we enable any decision making through the process that is recorded and traceable. So we used verifiable credentials. It's a technology that's coming actually also in Europe very much in all sorts of credentialing. And basically, all what we want to enable is, and especially because we have now the next pilot we have in a clinical assessment space, so in a health industry, where clinicians, they're making decisions, they're checking what AI making decisions, and they need to understand the reasoning behind the model. So shortly to say, we bring traceability and trust to the model that at the final stage, when you're actually looking at these results, you're able to see why a certain decision was actually made.
Yeah.
We're not changing it.
What I meant is that the explanations, how reliable are the explanations in the reasoning?
Oh, yeah, reliable. At least what we enable is that you understand why a certain decision was actually made. So the work I do, actually, the work I do is just we enable traceability of a certain pipeline.
So it's
And
traceability.
of course, traceability.
Because sometimes there are explanations that are plausible, but they are not the real explanations for the decisions that has been made.
Yes, yeah. And this is the area that's actually developing right now in front of our eyes. So everyone was jumping in all sorts of models, building this and bringing it to all sorts of industries. But actually, European Union is quite advanced in this. So actually, decision that was made just 10 days ago actually changed a lot. And then we had another decision also here in Australia that was in a medical space where a certain tool was actually refused for the use in a health space. And the reason was just, you can't bring a black box, a known box in a health space, and you can't do decisions like this. So it's a good signal. It's a positive signal. And for me and our team, this is just a huge challenge. We'll work on this. Yeah. If you guys want to follow what we do, find me on LinkedIn and we can communicate there. Yeah.
Tony, maybe you can share your email here in chat before we are closing down.
Yes, I will.
Alex,
yes.
And yeah, so because we are already after 20 minutes after the time, I would conclude this session, and I would very like to thank you, all of you, to be with us today, to take the time and to present your research works. It is a kind of excellent opportunity for all of you also to try to network with colleagues from other universities. There are some on this session and previous, and I think this is growing from each year. I was looking the statistic a little bit in between about the last year conference sessions and this year conference sessions, and I can say that we are seeing the trends and also the quality of work is improving. So from this sense, we can grow, and I'm also expecting that my dear colleagues that are now also working with me on the programs will have new mentorship on the next year edition of the conference. And with that, I'm concluding the session, and I wish you all pleasant evening and a lot of success in your careers and your research also further. This was from my side. Thank you very much to be on It's About People this year, and looking forward for next opportunity. Good night.
Thanks, everyone. Bye-bye.
Thank you, everyone. Thank you.
Thank you, Prof. Bye.
Bye.